Your second tutorial, question number 8, page number 4. There are two questions mentioned in question number 8, right? Come to page number 4. In your last tutorial, I put as PDF in the group. Go to page number 4 in it and take question number 8. The very first question at the top mentioning as 8. There are two questions mentioning the same number 8. The first one from the top we have. Yeah, take that question as the first question today. Today we're supposed to discuss 3 questions. So then we come to the end of this part and we start next week the continuity part. Okay, right. So now people come to this. Question number 8, it says, part A, d upon dx ln x 1 upon x 1 upon x. So this we did under theory part, people. So therefore we are not going to do this again. Okay, but that is okay, right? So next one is given like this. This part we have done in theory, right? We have done this in theories, right? Second one is this. X times ln y minus y times ln x equals 1. Asking to find dy by dx at x equals 1. At x equals 1. Right, people. Now start that. We have differentiated this. You have to follow here u into v form, here also u into v form. Right. How differentiate these people? We have to keep x as the same. Ln y derivative is what, people? 1 upon y dy by dx plus, keep this ln y, and derivative of x is 1 minus upon a bracket, keep this y, derivative of ln x is 1 upon x plus ln x you have to keep, and derivative of y is dy by dx. This is equal to right hand side, derivative of 1 is 0. Right? Yeah. Now asking dy by dx at x equals 1. Right, you know, people, here ln means what? Ln y means logarithm to the base e y. Okay. Okay. Okay, next one. I'm going to take this one again. X times ln y minus y times ln x given to be 1, no? Right. I'm going to find the ln y value when x equals 1, right? Using this, keep this for a while, right? Now, when x equals 1, put here 1 times ln y ln 1 equals 1. People, you know, ln 1 is logarithm of 1 to any base is people 0, no? So this is 0. Then this product will be 0. Then we get ln y is 1. Okay. So then ln y means really what? Logarithm of y to the base e, no? This is 1. Okay. How to eliminate this logarithmic form? This is y equals e to the power 1, no? Y equals e. What is this value of y? What is this value of y, people? This value of y means when x equals 1, the value of y, right? So therefore we can write, therefore y value when x equals 1 is what? E. Y value when x equals 1 is equal to E. That y value when x equals 1 we need to find dy by dx, put in x equals 1 here, right? Now people will come to this. I'll take this as star. Now by star. Now by star, put in x equals 1. X equals 1, right? So then what do you get there, people? Here, x equals 1 upon y, we write here x equals 1, and here dy by dx at x equals 1, right? And this ln y at x equals 1, this is how we write. And minus the y value at x equals 1, this is how we write that. When you put x equals 1, here 1, ln 1 is 0, people. Ln 1 dy by dx at x equals 1. This is equal to 0. Okay. Now x equals 1, people. Y value when x equals 1. Here we found. Y value when x equals 1 is E. Right. Put that E here. We get 1 upon E. Dy by dx value when x equals 1. And here ln y when x equals 1. Y value when x equals 1 is E. So therefore, for this y we have to put E. ln E. Right. In record. Here y value when x equals 1, it is E. People, ln 1 you know 0. This is 0. Okay. You can very clearly understand ln E is people 1. ln E is 1. So then you can subject this one. Okay. Bring this right hand side. And subject this. Then we get that answer. Upon E dy by dx x equals 1. Here we have 1 minus C. When you bring that to right hand side, we get E minus 1. Subject this. E times E minus 1. This way we get that answer. Right now? Right, people take the next one, part B in it. Part B, take that part B and start that question, people. Part B. Start part B in it. Yeah, part B, people say something like this. y equals x times e to the power 1 upon x. Right. Ask him to prove this relation. Right. Start that, people. Now we are almost the end of this lesson. So therefore, I think this kind of question should be able to work out yourself to get this answer. Right. I'll give you a few minutes, people. Get the answer. Everybody must watch, people, that 27th Sunday Corona class recording. In that class recording, I did 2019 and 2020, the two past papers questions. Okay, they are very easy questions compared to the questions we discussed. Okay, so we have to watch that and complete the notes. To get the recording link, first we have to send you a email address. So people, some students, they can't understand this process. Once you send your email address to me, people, I register you. So then you will get another email asking to activate your Zoom account. So then you have to just activate that. Okay. So thereafter, people, I am sending you the link of that particular recording. That also you will get into your WhatsApp. So then they are also, by using that link, you have to click that and small thing come into fill. In that included your email address, your password and name and something like that. Okay. So then you have to submit that. Then only you come toward the approval place of the recording. So then I can approve. Then only you get another email that you can you have the permission to watch the recording. So then don't do like that. Some people, they send me an email address and you are logging from another email, then you can't watch that. Okay, the same email you have to use. Okay, so those who haven't done so far that one, people, today itself do, right? Otherwise you can't watch the recording, because now the recordings, of course, you will be able to watch by using your produced email to me. So don't use any other email. You can't watch. Only the email you have registered here in the Zoom, you can watch the recording. Okay, and quickly do that one. Otherwise, there is a chance of deleting the recording, because now some recordings, of course, deleted, not in your ones, past 2-3 months before, some recording deleted here and there because of overuse this cloud space given to me. Okay, right. So now this one. Again, here we can apply, people, this u into v form. Then we can write dy by dx. Keep this u as the same. We have to differentiate this e to the power something. When we differentiate, first we get the same thing. Then that should multiply by the derivative of this power. 1 upon x. When you differentiate 1 upon x, people, 1 upon x, we can write as x to the power -1 taking this numerator. So then when you differentiate this, -1 x -2. This way we get, yeah. So then we get -1 x -2 plus e to the power 1 upon x. Derivative of x is 1. Right. Let me take this answer. Now, people, this is again, you can see x times e to the power 1 upon x. This is y, right? We get it as y. dy by dx is equal to, this is really y. Y, and here minus sign we have x to the power -2. We have people, this e to the power 1 upon x, this one, that can be subjected by this. How? Dividing by x both sides, then y by x coming, no, for this. Y divided by x. Now we have to differentiate this again because second derivative involving in the answer. Second derivative involving. So then what we do is people, we multiply this by x. Both sides, because in order to eliminate this denominator x there, then we can of course avoid differentiating the ratio, that means a constant. Okay, then we get x times dy by dx. When you multiply this by x, people, we get, right, shall we multiply this by x squared? Yeah, x squared multiply by x squared. Okay, so then we get x squared dy by dx. Here this x to the power minus 2 and x squared will cancel off, giving y. Then here we get people xy. Now differentiate this with respect to x again and take the next answer, right? Yeah. And then go to part C in it. Go to part C in it, right? Take as number 1 and differentiate this number 1 again with respect to x. Respect to x. Yeah, who got this answer, people? Right. Now keep this x squared, then we have to differentiate this using u into v form. X squared times this is second derivative plus dy by dx. X squared is 2x. Here minus dy by dx. People, this how to differentiate? Keep this x as same, dy by dx plus y, the root of x is 1. What's the answer asking? Yeah. Right. People, here in the given question, there should be minus sign. E to the power minus 1 upon x. Please correct that because I have worked out the question, but in the tutorial I haven't corrected that mistake. Please do that, people, again. That minus sign, something like that, we can see. Right. So then here, people, you get minus, no, and then this one we have to differentiate, no. So there, this minus sign we have to keep before this. Then we get another minus sign here, and another minus sign, because this minus sign you have to keep, and this minus sign, this minus sign come in when we differentiate this, taking this numerator, that minus sign x to the power minus 1, no, that comes before x to the power minus 2. So then here we get plus, no, people. This is plus now. This is y, no. This is y. This is really plus now. Then here, people, we get plus. Okay. Then here dy by dx, that way we get, no. Now see whether you get this answer. I think this time we get the answer, no? Yeah. Who got the answer? X squared times d2y upon dx2. Take this right hand side. Then on the right hand side we have dy by dx plus y. This 2, right? I am saying. Once you take this to right hand side, this will be minus 2x dy by dx. Here we have plus x dy by dx. Then when you simplify it, we get minus x dy by dx. Now people, I am going to multiply this again by x, because in the answer we have x cube. We have in the answer x cube, no? Yeah, multiply this by x. So we get x cube. d2y upon dx2 x times dy by dx plus xy minus x squared dy by dx. Right, people. Now, for this x squared dy by dx, for this x squared dy by dx here, put this y plus x side there and simplify. Then you get this answer. Then you get this answer right now. X cube d2y upon dx2 x times dy by dx plus xy, open a bracket, x squared dy by dx is this, y plus xy. This xy and this you can cancel down. Then only we get this answer. Minus y. Minus y, right? Yeah. That's okay. Right, people, now read it, part C. A continuous function f satisfies the following conditions. A continuous function f satisfies the following conditions. Right. First, people, read this and take that. Yeah, here you are given in part C, the continuous function f satisfies the following conditions. Right, following conditions. Right, these are the conditions given. People, if minus 1, what do you mean by if minus 1? Usually we know if x means what, people? If x is y, no? fx is y. Fx means the y coordinate of the graph, right? Okay, then I can, of course, categorize this like this. F minus 1 is 0. That means what, people? To get f minus 1 is 0 mean here to get f minus 1, right? To get f minus 1, we have substitute for x. What, people? Minus 1. Then only we get f minus 1. Then that says, this says when x equals minus 1, right? This y 0. Right? When x equals minus 1, this y 0. So therefore, when x equals minus 1, y equals 0. Then on the graph, minus 1, 0 is on the graph. Right. F0 is 4, people. F0 is 4. Second one. F0 is 4. What is this? When x equals 0, y is 4. 0, 4. F2 equals 1. F2 equals 1 means, people, when x equals 2, y equals 1. 2, 1. F5 is 6. X equals 5, y 6. Right now we got right. Next one. What's the next one? F dash x 0 only at f dash x 0 where x equals 0 to 5. People, f dash x 0 means what? Dy by dx 0 where at x equals 0 to 5. F dash x is dy by dx. Right, dy by dx becomes 0 at x equals 0, 2 and 5. That means dy by dx 0 means what, people? Stationary points. Right? Stationary points. Okay. Therefore, you can write stationary points. Stationary points at x equals 0. Right. Here, at x equals 0, dy by dx 0. But we have found at x equals 0, y is 4. Therefore, one station point is, first one is 0, 4. Next, this is it. The other station point is at x equals 2. Here, x equals 2, y is 1. Second station point is, people, 2, 1. This. The other station point is, people, 5, 6. There are 3 stationary points. Right now? Yeah. The next set of data, people, given that this way, f dash x less than 0. People, f dash x means what? Dy by dx. Dy by dx negative less than 0. In what intervals? In between 0 and 2 and 5 up to infinity. Right? Here negative and here negative. Right. F dash x positive to the left of 0 between 2 and 5, this, right? That is. Sketch the graph of y equals fx. Sketch the graph y equals fx. Right, people, now summarize this data and try to sketch the graph of y equals fx. I'll give 2 or 3 minutes. Here we are not given the x values where y or fx becomes infinity or negative infinity. That says this graph does not contain what? Vertical asymptote. Also, we are not given the fx value as x tends to positive infinity or negative infinity. That means this graph has no horizontal asymptotes as well. So therefore, we don't worry about those asymptotes in this case. Okay, now this contains only people stationary points, right? So then we know the stationary points can easily be constructed in this case. For first of all, we'll prepare that table. Since we don't have vertical asymptotes, we have to include only the x values where the graph has the stationary points like this. Right? Here positive, negative, positive, negative. Right now. Right. So then here, what do you get? Positive, positive, 0, negative. Here, maxima, no? Negative, 0, positive, minima. Positive, 0, negative, maxima. Maxima, right? Right now, you can sketch the graph, people. Now sketch the graph. Right, sketch the graph now. Right, now we'll sketch the graph. When x equals 0, here, y4. Okay. Somewhere here. 0, 4, we have maximum station point here. And next one, x equals 2 here, minimum. But when x equals 2, y is 1. X equals 2. I'll take somewhere here. Y is 1. Here 2, 1. To 1 point this. To 1 point. And x equals 5, Another stretching point, y is 6. 2, 4, 5. Y is 6. Somewhere here. Y 6. Okay. In the graph, people, we know no horizontal and vertical asymptotes for this graph fx. Only maximum minimum. Then the graph should be like this, no? Here it is the maxima. Minima. It's a maxima like this. This way it goes. Now horizontal asymptote means it goes to this way infinities. Goes to infinity like this. People, what is meant by the horizontal asymptotes? As x going to plus infinity or minus infinity, that y coordinate is going to a fixed real number. We are not given such information. That is because of no horizontal asymptotes. That means this interval, the gradient is positive, no, people. This way, this graph should go to this way. That means as we move to the left along the x-axis, the y coordinate of the graph is going to negative infinity. That's what it means. Right. This is the graph of y equals fx. Y equals fx graph is this, people, right? Okay, now what is asking next in it? Right. Sketch clearly the graph of y equals fx, right? Before that, people, I am going to find out this. This x coordinate, and here x coordinate, this. This x coordinate. Right, at this points, people, y coordinate of the graph 0. Okay, and then what I do is, in the graph, we are given f6 is 0. f6 0. f6 is 0. People, what is meant by f6 0? And f minus 1 0. Here. Y becomes 0 when x equals minus 1. Where should be that point? Y0 means on the x-axis. There are 2 points given. One is x equals minus 1, y0. Therefore, people, definitely this should be that point. Okay. People, another one given f6 is 0. That point we haven't taken into our consideration here. We are given another point as, people, this way, see, we are given something like this. f6 is 0. What is this, people? At x equals 6, y 0. At x equals 6, y 0. At x equals 6, y 0 mean this point. 6 0. This point. Right. Then the y coordinate of this fx graph becomes 0 at x equals minus 1 and x equals 6. Right. People, now using this, we need to sketch the graph of y equals fx. Y equals not fx, 1 upon fx. Right. Using this graph, we have to sketch y equals 1 upon fx. Right? Yeah. Now try to get the y. Try to get the y equals 1 upon fx graph by using this fx graph. Right. Now, this is the fx graph. Here, fx. People, fx means y. What is y here? Y means the y coordinate of this graph. Now, for example, when x equals 0, fx means this height. When x equals 2, fx means x equals 2 is here. When x equals 2, fx means at that x equals to the y coordinate, this height. Is the fx value when x equals 2. Okay. Right. So then when x equals -1, fx means the y coordinate of the graph, 0. When x equals 6, fx means y coordinate of the graph, 0. Right. Then people, this is how we sketch the y equals 1 upon fx. Right. Remember people, this fx means what? Y of this graph. Y of the graph view or drawn. Fx means y of the graph drawn. Right. People, can you remember here? At x equals -1, what is this y coordinate? 0, no? Then you can see here, at x equals, first one, at x equals -1 and x equals 6. Okay? -1 and 6. What can say of this graph? Y 0. That means this is 0. When the denominator becomes 0 means people, what do you get? 1 over 0, infinity. Understand? Okay. This goes to infinity. At x equals -1 and x equals 6, since fx 0, y goes to what? Infinity. We don't know whether it is plus infinity or minus infinity. This graph, 1 upon fx graph, its y coordinate goes to infinity when we are x equals -1 and 6. What do you mean by this? For the graph 1 upon fx, it has two vertical asymptotes. Where at x equals -1 and x equals 6. Therefore, y equals 1 upon fx has vertical asymptotes at x equals -1 and x equals 6. Okay, right. That is first thing. Okay, right. Next one, number 2. Right, you can very clearly understand here. At this point, this has minimum, no people? This y has minimum point. The shape is minimum. You know, this fx, here y coordinate mean people, fx, no? When this fx is minimum, in a fraction, if the denominator is minimum, the fraction value is maximum, no? So therefore, people, since at x equals 2, this height minimum, denominator minimum. When the denominator is minimum, people, what can say the fraction? Fraction takes maximum. Understand? So therefore, at x equals 2, this graph has what? Maximum. Right? Yeah. At x equals 2, fx minimum. Fx minimum. Therefore, y equals 1 upon fx has what, people? Maximum. Maxima. Where? At x equals 2. At x equals 2. Right. X coordinate is known to be 2. Huh? Then what is the maximum point? Yeah, people, this height is what? 2, no? Fx is 2. And then when you put that 2 here, y comes as what, people? 1 upon 2. Half. That means when x equals 2, y is half. At that point, there is a maximum. Okay. What is that point? Y equals 1. X equals 2. Sorry. X equals to y equals 1. No. Here, x equals to y equals 1. No. Right. Then we get y equals 1. Right. X equals 2. This y quantity is 1. No. Right. X is 2. Y is 1. So therefore, we get at x equals 2, y is 1. Therefore, 2, 1 is a maximum. Is a maximum. Right. Another thing, people here, remember, here we have a maxima. Fx comes to the maximum values here and here. Right? When the denominator is maximum, people, what can you say about this fraction? Fraction minimum. So therefore, 1 upon fx graph has 2 minimum values. Where? One is at x equals 0, other one is at x equals 5. Understand? Right. Then we'll come to that too. Right. Number 3. Y equals 1 upon fx has maxima at where, people? Right, minima, not maxima, minima, no? Minima. Why do we say minima? Because when the fx is maximal, then 1 upon fx is minimum. That's the reason, right? That's the reason. Okay, y equals 1 upon fx has minima at where, people? X equals 0 and x equals 5. Right. At x equals 0, what is y coordinate? 4, no? Fx 4. Then once you put 4 there, 1 upon 4. Therefore, at x equals 0, y is 1 upon 4. Then 0, 1 upon 4. 1 minimum point. What is the other one? X equals 5 when you put here, 1 upon 5. Then we get 5 comma x equals 5. What is x equals 5? X equals 5, y 6, no? Y 6. 1 upon 6. X equals 5. Y is 6, no? Yeah, 1 upon 6. Then y equals 1 upon fx graph has 1 maxima and 2 minima. Okay. Now people, next one. You can see here, when this when we move along the x-axis to negative infinity direction, when you move along the x-axis towards negative infinity direction, what can say this? Why? Y going to negative infinity. Right. Okay. Then next one. Next one, right? Number 4. As limit x going to negative infinity. People, what can you say about this fx? Fx going to negative infinity, no? Right. Fx going to a fixed limb going to negative infinity. That means this is going to negative infinity. 1 upon negative infinity means what, people? 1 upon infinity is 0. Then we have minus sign, no? Minus 0. There is no call something minus 0. So therefore, what can say? As limit x going to negative infinity, right? 1 upon fx going to 0. Why? This is negative infinity means 1 upon infinity is 0. What is this? This graph has horizontal asymptote where at 0. That's how we define, no, people. As x going to negative infinity and positive infinity, if y goes to finite value, at that value of y, there is horizontal asymptote, right? Similarly, we can write as limit x going to plus infinity. Okay? When we move this way to the right, this depth, people, negative infinity. Then 1 upon negative infinity means again 0. 1 upon fx going to 0. Right. Now, people, you can sketch 1 upon fx graph. Right. Now sketch that. Right. I, of course, got this all data we are here. Right. Now I can sketch the 1 upon fx graph like this. Right. We have vertical asymptotes at 6 and minus 1. You see, people. Vertical asymptotes we marked. 2, 1 maximum. X is 2. Y 1. To 1 maximum. 0, 1 by 4 minimum. X is 0 here, no? 1 by 4. Here minimum. Here maxima, here minimum. 5, 1 upon 6. Right. 5 somewhere here, no? 1 upon 6. Smaller than 1 upon 4. Right. That's the minimum. Right. Okay. So then the graph should be like this, no? Here maxima, here minima. This way. Right, people. Now you can very clearly understand. In order to keep here minima, people, this branch should go this way. So therefore, when we go closer to this 6, this should be this way. Here we have to keep a minima. Then this branch should be moving to this direction. Right. This point we know. This point is people 0, 1 upon 4. This point is 5, 1 by 6. Right. Now, next thing, people. The horizontal asymptote parts. That means the rest two parts of the graph on the right hand side of 6 and left hand side of -1. That too we have to sketch. How to sketch that? We know what people? As we move along the x-axis to the right, y coordinate coming to 0. As we move negative infinity direction along x-axis, y coordinate going to 0. Right. Now, the way of drawing this, see like this, people. You can see here, look at this. On the right of 6, this y coordinate, people, here, negative. Y coordinate is negative. Right? Okay. People, now, suppose like this. I'm going to calculate this y value 1 upon fx. Right? This fx means you know the y coordinate of this graph, no? Right. Now suppose here on this x-axis we have 100, suppose 1000, and this 100 and this 10. This x-axis, no? Right. Okay. Now when we come to people to the 6, this point, from this right we come to this 6. Right. Somewhere x here, I'll take this height minus 1000. Then we have to put here what, people? 1 upon -1000. What do you get? Minus, right? 0 point something. This we get, no? We get like this. Okay. Okay. Now, like this, when you come, people, this way, you can very clearly understand. Okay. You can very clearly understand this denominator fx, keeping minus sign before that, this gap, this height decreasing, no, people, here. This height decreasing here. Keeping minus sign before, this thing decreasing. That means this thing coming to 0. 1 upon 0 is, people, infinity. 1 upon 0 is infinity. Here we get 1 upon 0, because when we come to this 6, this way this depth decrease into 0. But keeping minus sign, that minus sign only I have put here. 1 upon 0. What is this, people? Infinity. But before that we have minus sign. Then can you tell me, when we come from this end to this 6, when we come from this end to the 6, the y coordinate, that means 1 upon fx going to be minus infinity. And that means when we come this way, people, the y coordinate of this graph should go to minus infinity, to this sense. Understand? So therefore the graph should start this way, no? We draw that like this because at y equals 0, there is horizontal asymptote. Like this. Okay, now we know, right? Now, when you move this way, people, again fx is negative. Then same thing happens, no? As before. Then how do you draw this one? This. When you move to what? Distance. Okay, people. When you come towards -1, this gap is decreasing up to 0. Keeping minus sign before denominator becomes 0 means going to minus infinity. This minus infinity is this. This is. This is the 1 upon fx graph. 1 upon fx graph. Right. People, any question here? Even another part is there. Okay. Ask another part. Hence find the number of roots of the equation ln x fx minus 1, right? Ln x into fx minus 1 equals 0. Hence find. Using this graph, you have to find that. People, we know soon enough to draw in a graph like this, and if there is particular equation, to find the solution of it by using what? This graph. What's our usual practice, people? Definitely by that given equation to solve, we should be able to obtain the equation of the graph we drew. That's the way. First of all, we have to take that equation of the graph. What is that? 1 upon fx, no? We have to bring 1 upon fx from this equation given. Okay, so then once you bring this right hand side, ln x fx equals 1. Bring this here. Ln x equals 1 upon fx. 1 upon fx. Then people, this equation mean what? This equality. Then the solution of this equation mean x coordinates of the points of intersection of this graph just now we drew and ln x graph. Okay, people. The solution of this equation star mean what, people? Yeah, we can write that equation star like this. What is this? 1 upon fx means the graph we just now drew. Okay. And ln x graph. When we draw ln x graph, ln x means, people, y equals log x to the base e graph is the ln x graph. When we draw y equals log x graph to the base e on the same plane, that graph and this y 1 upon fx graph intersect at some points. For those points, people, there are x coordinates. Those x values are the roots of this star. Okay, yeah. Then now we have to draw this y equals log x graph. Okay, then we'll start from here. Reaching here, we'll write one sentence like this. Put this as star. After reaching here, write down one sentence like this. The solutions of the given equation star are the x coordinates at the points of intersection of the graph y equals log x to the base e, y equals log x to the base e, y equals log x to the base e and y equals 1 upon fx, and y equals 1 upon fx. Okay. Now, people, we have to draw this graph. We have to draw this graph. Then we'll try to draw y equals log x. Y equals log x. How to draw this graph, people? Y equals log x will be, bring this e to this side. This gives us e to the power y equals x, no? That, in other words, x equals e to the power y. Now you can write first one, what, people? Number 1, put y0. Y0 brings e to the power 0. X, e to the power 0, 1. X equals 1. So therefore, graph passing through 1, 0. Okay, now, people, when you put y0, e to the power 0, 1, x is 1. Graph passes through 1, 0. 1 is here. Graph passes through the point this. Right. Number 2. Second one is, people, we can say second one, see like this. As lim y going to infinity. Now, put, people, here infinity for this y. What do you get? E means 2.71. 2.71 to the power infinity. Infinity, no? X going to plus infinity. Limit x going to plus infinity. All right. Now, earlier we said graph passes through 1, 0. Graph passes through x coordinate is 1, y coordinate is 0, 1, 0 here. Right. Secondly, as x going to plus infinity, that means this way. Y going to plus infinity. The height increasing. Right. That means the graph should be like this. Then only when we move to positive infinity direction of x, y height increasing. Right. Let's see, people, another one, number 3. As limit y going to negative infinity. I substitute for this y, negative infinity. Right? What can I say? X e to the power y. Y is now negative infinity. This e to the power negative infinity I can write as 1 upon e to the power infinity. People, e to the power infinity is infinity. X going to 0. What do you mean by that? As x going to 0, that means x going to 0 means when we come closer to the y-axis. Right here. This one you can write. Therefore, as lim x going to 0, y lim going to negative infinity. That means when we move closer x0 this way here, x0 come in when we come closer to y-axis this way, x0. When we come towards y-axis, the y coordinate of the graph is going to where, people? Minus infinity. Right. By considering these 3 facts, people, can you draw the graph now? Yeah, the graph should be like this now, people. See here, when we come closer to x0, x0 means x going to come into 0. The last point says y going to negative infinity. Correct? No, this is the negative infinity direction of y. Correct? No? When we come to 0. This is 1, 0 point. That also we notice now here. X equals 1, y 0. Second point, as x going to plus infinity, y going to plus infinity. X going to plus infinity mean when you move this way, y should be plus infinity like this. This is the graph. This is the graph, people, of what? Y equals L in x. Okay. Now, how many points of intersection you can see there for the 1 upon fx graph and L in x? See? L in x graph is this. 1 upon fx graph is the early one. For them, there are 2 points of intersections here. Here and here. There are therefore 2 solutions for this equation. Okay, there are 2 solutions for the equation. Then you can write. Therefore, the equation star has 2 solutions for x. Has 2 solutions for x. Has 2 solutions for x. Right, people? Right. So this question, people, really nobody can work out within half an hour, but we should be able to work out this question within half an hour. And history of combined maths, no question this way. No question this way. This question has more work, people, but there can be this kind of question in the future. Anyway, people, in the term test, definitely this kind of question, though we expect, people, that is fair because there's a chance of coming. Because you can very clearly understand, here we learned lots of maths in it. So that is why I thought of doing this question. By this, you can learn a lot. Without doing this kind of questions, people, if you go forward, people, right, you don't know that you don't know, people, that you don't know that much of this. That's a risk. Therefore, people do this kind of question again, the same question again. Some questions available in the tutorial. Do. Right. Now, we come to the next question. Well, you want a break? Now, take question number 8, page 4, the second 8. Usually in my tutorials, the same question repeats again. No? Right. There are 2 questions mentioned as question number 8, page number 4. The second 8, take that question. It's first we'll do part B. Right? Page number 4, question number second 8, the bottom. It's part B. Right. I'll take that as the next question. Let's see. Right. Take this. Read that question, people. Right, people, this way a piece of cardboard given. Then can you understand the way of preparing this or forming this box? Now it is formed like this, people. Now along this edge, this portion folded up this way. Along this line, this is folded up like this. Along this, folded up like this, and along this, it is folded up like this. Then what kind of box is coming, people? You see a box is coming. This way. Okay. This is given as x. This is a square root, this part, this is also x. This is 6. This is 6. This is a square. Then here to here, this length. We are given 16 now. Right. From here to here, it is 21 centimeters. Right. Well, if we take this as y, this is also y. This is 6. This is 6. Then people, this bottom, this length only here we have. This length only here we have. This is therefore, this thing is y. What is this thing? This portion, whole thing is 16 minus 2x. This is 16 minus 2x. Right. People, by this portion, what we get? By this only, by folding along this line, we take what, people? Take what? This upper part. All right, that in the sense, people. So we are given here closed box, no? Right, here you are given closed box. So then people, by this portion, what parts of the closed box are covered? Can someone tell me? By this portion, this part is covered. You can understand that very clearly. By this portion only, this bottom covered. This side covered by this. The opposite side, this covered by this portion. Then people, another two sides to be covered. What? This side and this side. That two sides will be covered by these people. People, what is the height of this box? Height going to be, people, this 6, no? This is 6. This is height. Then that height should be covered by this portion. Therefore, we have to have x here. Along this line, it is, this one is folded. Then by this portion, only we cover this part. What is that, people? It is y. Then you can very clearly understand this portion should be y. Is it clear? If you don't get this idea here, people, you can't get the equation involved in this. Is it clear, people? Any question? Now, this given piece of cardboard, people, along these edges, dotted lines, we fold them. This is this way. That gives this portion, the shaded portion, right? This part this way. That means the other side given by this. This is the bottom. This. By folding this way, people, what do you get? This side. Then we covered how many sides? Bottom covered, other side covered, this side covered, this side covered. Another two sides to be covered. This side and this side. That two sides only, people, we cover by this. How? First we fold this along this line, and we fold along this line by this portion, this side. By the rest portion, this top is covered. Okay. Now you know, after forming that way the box, people, what should be the height of the box? Height of the box, people. Now, when you fold this way, this length is the height. Just this. Such height we need from this end. That is given by this. Then of this whole length, we have to remove a portion x to fold around this line and this line to cover up this. The rest one, we have to cover this y. So therefore, the whole length of this from here to should be x plus y. Right. Now we write what? We write what? The equations. People, what are the equations we can write? This length x, this length y, this length x, this length y. Their total should be what? 21. Therefore, you can write this is x, this portion, this is y, this is x, this is y, equals this whole length 21. We get what? 2x plus 2y equals 21. Number one. Right. Here, this is 16 minus 2x. This is y. And what is asking, people? Obtain an expression for the volume Vx in the box. People, can you tell me what is the volume of the box? Base area multiplied by height, no? What is the base area? This is 16 minus 2x, this part, no? And this is y. And then the volume Vx given, base area 16 minus 2x into y into height x. Okay, height is x. Right, we got that. Now, second part, find the side of the square which should be cut off so as to maximize the volume of the box to be formed. Right. So now, people, volume function we got, it contains y. That y we can replace by number 1. Then this volume function will be coming only in terms of x. Now you can do the rest part. Right. Do the rest part, people. Do the rest part. Right. We can subject y, people, by this. Y number 1, y is 21 minus 2x divided by 2, no? Put that here. Then we get volume. We 16 minus 2x times x people and y. 21 minus 2x by 2. 60 minus 2x and x and this y, 21 minus 2x by 2. By this 2 we can cancel down here. 2, 8 and 1. 8 minus 6 times x, 21 minus 2x. Right, so then we can multiply by this. 8x minus x squared, 21 minus 2x. This is what we get, right? We have differentiate this. We need to find this value of x so as to maximize the volume. No? Yeah, this x one we need to find. Now we take this as u, this as v. We can eliminate the brackets also, but we'll take like this. dv by dx, 8x minus x squared into when we differentiate here we get minus 2, no people, plus 21 minus 2x into here 8 minus 2x. 8 minus 2x. Now we can take minus 2 out. Also take minus 2 out. 8x minus x squared. And when you take minus 2 out, people, here we get x minus 4. When you take minus 2 out, x minus 4 come in here, 21 minus 2x come in. Right, no? Now we have to simplify this, remove the bracket. Here we get what, people? Minus 2x into x minus 2x squared minus x and x squared. Right. And here we get 4 and this 2. 8x, right? Minus minus plus 8x and 21x, 29x. 29x plus this 8x. 37x, no? And what do we get next one?